In this lesson, we're going to go over the definitions for exponents, square roots, and absolute values. So starting with the definition for an exponent, if you have x to a power of n, what this means is repeated multiplication. So you take x and you multiply it by itself n times. So maybe as like a quick example, if you say x squared, well, this means x times x. Or if you have x cubed, that's x times x times x, a total of 3 times. Or if you just had, let's say, x to the first, well, that's just x, and you stop there. Let's apply this definition in example 1. So starting with this 5 to the power of 3, what this means is, by definition, take 5 and multiply it by itself 3 times. 5 times 5 is 25, times 5 more is 125, and that's our final answer. And of course, you should have a calculator out and you can verify that this is true, but that's it. 5 cubed is equal to 125. If we compare that to negative 2 to the 4th power, so because of these parentheses around the negative 2, it means you're copying down that negative 4 times as well, so not just the 2. If I'm being very careful, this means negative 2 times negative 2 times negative 2 times negative 2. If you encounter a negative in this case, all you need to know is that since there is a total of 4 negatives, they multiply to give us a positive value. So I can ignore that negative at this point. I know the answer is going to be positive. So the last thing you have to do is multiply 2 times 2, which is 4, times 2 more is 8, times 2 more is 16. So the answer is going to be a positive 16. Now, if you compare this to negative 2 to the 4th, because there are no parentheses that include this negative, the exponent of 4 applies to just the 2 first, and at the very end we'll multiply everything by negative 1. So by that I mean, this is negative, but then 2 gets multiplied by itself a total of 4 times. So in this case, since there's only one negative, the entire answer is going to be negative, and 2 times 2 times 2 times 2 is 16. Okay, so that's important to compare these two. The negative inside the parentheses actually made the answer positive. The negative outside, it stayed negative. All right, let's see what we have here next. 1.21 to the 5th power. So for this one, I'm going to go right to my calculator. You should have a function that you can take 1.21. There's like a caret that appears in mine, and you can put a 5 after it because I don't really want to do this out by hand. So let's see, 1.21 to the power of 5. Okay, I'm going to write down the entire value, but it's 2.59374246, and it stops there. So for a lot of the computations that we do, it'll be handy to have a calculator on hand. So for the last couple here, this technically does not fall into the way I defined an exponent, since the actual exponent I said has to be 1, 2, 3, 4, 5. And here we have 0. Any non-zero number, like 7, to the power of 0 is going to be equal to 1. So we could actually add that into our definition. Anything to the power of 0 will be equal to 1, except if x is 0. So if we look at this last example, 0 to the power of 0, well, what should that be equal to? This, if I type it into my calculator just to check, 0 to the power of 0, it actually says error. It might say something different on yours, but it actually does not give me an answer. And the reason for this is that it's undefined. In all other cases, the exponent is defined, and that is it for this definition. The next definition is the square root of a non-negative number a, which is denoted with this symbol here. It's defined to be the non-negative number whose square is equal to a. So it's a very formal definition, and you probably have some familiarity with how this works. Plus, we can check it on our calculator. Let's look at example 2, starting with the square root of 25. So you're probably familiar that the answer here is equal to 5. You can type that in a calculator, you get that no problem. So going back up to this definition, the reason that 5 is equal to the square root of 25 is because if you were to take your answer, which was 5, and you square it, it gives you 25 back. So you can think of the square root as the inverse of squaring. So again, that is the square root of 25 is 5, because if you were to square 5, it took you back to 25. The reason for this non-negative portion in the definition is because, well, 5 squared equals 25, but negative 5 squared is equal to 25 as well. So it's kind of like, well, what should the answer be? Should it be a positive 5? Or should the answer be a negative 5? And we have decided to use the non-negative number as our answer. But like I said before, you probably already knew the square root of 25 is equal to 5, and that's good enough, and you can check it in your calculator. So if we use this idea in the square root of 36, well, the answer is going to be 6, because if you were to take 6 and square it, that gives you 36 back, and the number that we use, 6, is in fact non-negative. Great. But then we come along to the square root of 30, and there isn't a number that is jumping out at me that's going to be a perfect answer, so I'm going to go to my calculator. I'm going to type in the square root of 30, and I get 5 point, and it's a decimal that goes on for a little bit, so 477225575, and actually this thing goes on forever, but there's just only so many places that appear on my screen of the calculator. In a case like this, we'll just leave the answer as the square root of 30, just because that is a more concise way of expressing the answer as opposed to writing out the decimal. So kind of like up to this point, if you have a square root and it can be reduced to a number that doesn't go on forever, then we'll do that. However, if we see something like this that gives us this repeating decimal that goes on forever, we'll just stick with the square root of 30. Last couple of things to consider here would be, well, what's the square root of 0? And if I put that into my calculator, it tells me 0, but that makes sense because if you were to square 0, you get 0, so there are no problems there. 0 is non-negative. Great. And then the last one we have here is the square root of negative 100. And if I type that in my calculator, again, I get this error, is what it says on my screen. And the reason for this is, if you try to think of something that when you square it, that would give you a negative 100 or any negative number, nothing works. You can't actually place anything in there, square it, and get a negative number back. There is such a thing as imaginary numbers, which we won't really be using in this class. So if we do see the square root of something that's negative, what we'll do is just say there is no answer and move on. And for our last definition, the absolute value of x, denoted with this symbol x with 2 vertical lines on either side of it. This is the distance the number x is from 0 on the number line. So what that means, if you draw a number line, and we'll put 0 right here in the center, what would the absolute value of 5 be equal to? So 5 is over here, and the distance that you have to travel from 0 to 5, well, not very surprising, it's actually equal to 5. Where things get meaningful in this definition is if you were to ask, well, what's the absolute value of negative 5? So negative 5 means we're moving in this direction. The absolute value would represent the distance that this is from 0. And distance should always be recorded as a positive number. So sure, you did go 5 places to the left, but we'll say the absolute value of negative 5 is also 5, since 5 is the distance that we moved. So if we use this idea in example 3, we have the absolute value of 15.1. And all you really need to ask yourself is 15.1 positive or negative? Well, it's positive, so therefore the answer is just 15.1. Whereas if you had the absolute value of negative 12, well, the answer would be positive 12 instead of negative 12. The only way things could get confusing is if you had the absolute value of something that, well, maybe you're not sure if it's positive or negative. Like here we have the absolute value of 1/3 minus 1/2. What is that equal to? So to figure this one out, I'm just going to do a little bit of work on the side first. What is 1/3 minus 1/2? It might be useful for us to simplify that to know if it's positive or negative, and then apply the absolute value next. Okay, so we have 1/3 minus 1/2. I need a common denominator, and 6. 6 will work. I can multiply this first fraction by 2 to get to 6. That means the numerator is going to be 2. Because if I double 3, I get 6. And if I double 1, I get 2. Applying this same logic for our second fraction, if I want to go from 2 to 6, it means I'm multiplying by 3. So 1 times 3 is 3. Now that I have a common denominator, I can simply subtract the numerators. So the denominator remains 6. The numerator is 2 minus 3. And 2 minus 3 is negative 1. And you could write this as negative 1 over 6, since we're basically saying the whole fraction is negative. So a lot of work there in the middle, but this question is really asking, what is the absolute value of negative 1/6? And the answer would be positive 1/6. And that is it for example 3.